Okay, this is problem 368 in the problem solving videos, and it says find V0 using loop analysis, and we're going to be utilizing the problem solving strategy on page 117 in the text. You can see where V0 is labeled on the circuit, and when we do loop analysis we pick the currents where there's only one loop current that passes through a current source. So we have that one current source, and if we look, we really have a three-mesh circuit here, so we're going to need three loop currents. So if we go to pick the loop currents where only one passes through that current source, I'm going to go in and select this loop current as the only one to pass through that current source. I'm going to call it I2, and then I'm going to assign loop current I3 to that loop, and then for my third loop current I'm going to select loop current I1 as shown. So now we have three loop currents, I1, I2, and I3. Now we know one of the loop currents, in fact I2 is 2 milliamps, and we know that by the way we picked the loop currents. So now we have two unknowns, two unknown loop currents, I1 and I3. So we're going to need to write two equations to solve for those. And the way we're going to get those two equations is we're going to apply KVL around loop 1 and loop 3. And let's start with loop 1. Okay, so as we start with loop 1, we'll start over here and go around. We'll have 2K times I1. There's a drop across that resistor. Then we'll have 3K times I1. And that's a drop across that resistor. For this resistor, we'll have 4K times I1 plus I2. Then we'll have minus 12 for that source. And then continuing on around, then we'll have, for this resistor, we'll have 6K times I1 plus I3. And then we'll have, if we continue on around, we'll have minus 10 equal to 0. Okay, so there's our equation. Let's work on that equation. And if we collect up terms here, for instance, we'll have 15K I1 plus 4K I2 plus 6K I3 equal to 22. And if we substitute in I2, we'll have 15K times I1 plus 4K times 2 milliamps plus 6K times I3 is equal to 22. And if we go in and simplify that some more, we'll have 15K I1 plus 6K I3 equal to 14. Okay, so there's one of our two equations, and that's, we got that one by applying KVL to loop 1. Now we need to solve for our other equation. Okay, so now we need to apply KVL to loop number 3. And if we start here and go around the loop with the loop current, we'll have 3K times I3, and then we'll have 6K times I3 minus I2. That's a drop associated with this resistor. Then we'll have 6K times I1 plus I3. That's a drop associated with this resistor. And then that minus 8 equal to 0. So now if we simplify this equation, we'll have 6KI1 minus 6KI2 plus 15KI3 equal to 8. And then if we substitute in, we'll have 6KI1 minus 6K times 2 milliamps plus 15KI3 equal to 8. This has a value of 12, so then our equation becomes 6KI1 plus 15KI3 equal to 20. There's our second equation. Now, let's write our equations in matrix form and solve them using MATLAB. So in matrix form, we'll have 15K, 6K, 6K, 15K. We'll have I1 and I3. And then we'll have 14 and 20. And then using MATLAB, we'll get I1 equal 0.476 milliamps, and then I3 is equal to 1.143 milliamps. Now, let's go back to the circuit very quick and say, okay, how do we calculate V0? If I look at V0 at this resistor, there are two currents flowing through that resistor, loop current I1 and loop current I3. So then V0 is going to be 6K times I1 plus I3. So that's 6K times 0.476 milliamps plus 1.143 milliamps. So V0 turns out to be 9.714 volts.